So to carry on from the previous video, as you can see here in this particular video, we mentioned about the halite crystal being three-dimensional cubic. We mentioned having a sodium atom. We mentioned having a chlorine atom. If you remember, sodium got a charge of +1, so that means that the sodium is willing to lose one electron, and chlorine got a charge of a -1, which means that chlorine is willing to gain one electron. So the one that the sodium loses is the one that the chlorine gains. And so it's a transfer of electrons, so we know it's an ionic compound. And so this is a Bohr diagram here on the bottom of a sodium ion and a chloride ion together in an ionic bond. And so they are all throughout a three-dimensional cubic crystal of there's a lot of elements on the periodic table. I think there's approximately 115 elements. But when we're talking about the crust, and remember the crust is found in the lithosphere. So there's two types of crust, continental crust and oceanic crust. So really when we're talking about the crust, there's 8 elements that are really, really important. And they are Ottawa Senators are insane. Calgary should play Montreal. So this is a little mnemonic that I use to remember this. So it stands for Ottawa stands for oxygen, Senator stands for silicon, R stands for aluminum, insane stands for iron, Calgary stands for calcium, should stands for sodium, play stands for potassium, and Montreal stands for magnesium. And so these are the percentages of each one as well. So as you can see, 46.6% oxygen, 27.7% silicon, 8.1% aluminum, and 5.0% iron. I would suggest that you only study the percentages for the first 4, so Ottawa Senators are insane. I really wouldn't worry about the percentages for Calgary should play Montreal. Now, these are the top, and I call these the Great 8 elements that represent the minerals that you find in the crust of the earth. But remember, this does not include the inner core, the outer core, the mantle, the asthenosphere, only the crust. So an example of a public exam type question would say, which 2 elements are the most abundant in Earth's continental crust? So immediately you see that they're talking about the crust, and you think about Ottawa Senators are insane, and you look for oxygen and silicon. So the elements on the periodic table, a lot of them you should know from just being in school throughout your whole life so far, and the symbols. So for example, if I said lead, Pb, nickel, Ni, cobalt, Co, calcium, Ca, is not a big deal if you don't know the elements and if you don't know the symbols. The biggest thing I'm trying to show you here is that elements combine to create compounds, and compounds are elements. So if we were to look at the mineral which we call fool's gold, which is pyrite, we can see that 2 elements are combining to form a compound. In this case, it's iron and sulfur. So iron and sulfur combine to create a compound, and that compound is a mineral called pyrite. Here we see Pb and S, so lead and sulfur combines to form a compound, and we call this compound galena, which is the name of the mineral. Na and Cl combine to form a compound, and we call that mineral halite. So elements combine to form compounds, and compounds. What is a mineral? 5 things. A mineral has to be naturally occurring, it has to be inorganic, it has to be solid, it has to have a definite chemical composition and a definite structure. So anytime you're ever asked if something is a mineral or not, always question those 5 criteria that make up a mineral. So it has to occur in nature. Humans can't have anything to do with it. It has to be inorganic, not alive, never ever was alive. Solid, can't be a liquid, can't be a gas. A definite set of chemical composition, so what it's made of, and structure, how it's structured. Okay. Most minerals, as we said earlier in this presentation, are compounds, but there are some minerals that are in fact elements. So like gold is an element, silver is an element, sulfur is an element, but they're also minerals. Carbon is an element, but carbon can be found, pure carbon can be found in 2 minerals, one called diamond and one called graphite. Copper you typically find in compound with other elements, for example chalcopyrite, but it is also possible to find native copper. So this gives the question, explain why or why not synthetic diamonds could be classified as a mineral. Well, synthetic diamonds are created by humans in a laboratory. So therefore, they could not be classified as a mineral. That's why synthetic diamonds are so cheap. Synthetic diamonds fail the criterion of naturally occurring. Okay, so they have to occur naturally in order to be a mineral. Explain why or why not oil and gas and coal could be classified as a mineral. Well, gas is not a solid, oil is not a solid, so they fail for that reason. Okay? All three are made from living things. So coal is made from plants, oil is made from microscopic animals, gas is made from microscopic plants. And we said that a mineral has to be inorganic, which means came from something that was not alive. Okay, never alive. So a mineral cannot come from something that was alive at some point. It has to be inorganic. There's a lot of minerals on the planet. There's over 4,000. Here's the number of minerals that you need to know for this course. Just 23. Now, you got to remember, though, that every single mineral got various different mineral properties. And so 23 minerals, by the time you know all the different properties of each one, is actually a considerable amount. I venture to say that even a mineralogist who works with minerals day in, day out, doesn't know all the properties of the 4,000 minerals that have been discovered on Earth so far. Now, the beauty is, every single time that you have a mineral, each mineral is classified into a group, a mineral group, and there's only 7 mineral groups. So if you were to find a new mineral in the St. John's area that has never been discovered ever before, the first thing that you would do is you would study the properties of that mineral and you would group it into one of these 7 groups. So it's either a silicate or a carbonate or a sulfate or an oxide or a sulfide or a halide or a native element. If you remember earlier when we talked about Ottawa Senators are insane, Calgary should play Montreal, remember that we were only talking about the Earth's crust, and they were the great 8 elements that make up the minerals and rocks of the Earth's crust. And also remember Ottawa Senators. So Ottawa stands for oxygen and Senator stands for silicon in that particular order. So there's always more oxygen than what there is silicon. There's a reason for that. There is a mineral group, it's one of the 7 mineral groups, and it's called the silicates. The silicates truly are the most important, the most dominant, the most abundant group of all when we're talking about the crust. And the silicates are made up of silicon oxygen tetrahedrons. So when we talk about minerals having a definite structure, the structure of silicates is the silicon oxygen tetrahedron. Here is a picture of what the silicon oxygen tetrahedrons looks like. So here in the middle you got a little silicon, and then you have, and just for people who done chemistry before, silicon has a bonding capacity of 4, which means it can bond with 4 other things. In this particular case, it bonds with an oxygen, it bonds with another oxygen, and another oxygen. So for every single one silicon, there's 4 oxygens. That's the reason why it's called Ottawa Senators and not Senators Ottawa, because there's way more oxygen than what there is silicon. So always remember that. So there's more oxygen than silicon, and tetra stands for 4. So think of it as 4 oxygens for every 1 silicon. All right, and so this, and just picture that and have an idea of what the structure actually looks like. And that is it for this video.